Okay, so um, okay, when we have the robot, so
Yes.
um, okay, task is win the game. So what do you think needs to happen? Doesn't matter like in which order, but yeah.
The robot has to listen to the game controller because it will get disqualified
Okay,
if
listen
it's
to
not listening.
game controller. Okay, what else?
Detect the ball and kick it into the goal.
Okay. Detect the ball, right? So, so kick, right? But what do you think needs to happen so you can kick the ball?
You need to know how far the ball is away from your feet.
Okay, so we need to have like some sort of idea where we are or where things are relative to us, right?
Self-localization
Some
and localization.
of localization, right? So
Yes.
so I'm phrasing it like this because like there's multiple ways on how to do this. So first of all, maybe you know exactly where you are on the field and detect everything, and then know exactly where the ball is and where it should go, right?
Yep.
And then okay, you do some. That's basically just a geometric problem. Figure out where the ball is relative to you. Go there, and then kick the ball in the direction where it should go, right? But
Yep. You don't know already know exactly.
Technically, you don't need to do this, right? So, I mean, okay, we want to win the game, right? So this is like a faraway goal, right? So if you don't think about this at all, and instead look at what the rules say, the rules say the only thing we need to do is listen to the game controller.
Yes.
So actually, this is the only thing that we actually need to do.
Yeah, but we won't win.
Yeah. But the important thing is this is the thing that we absolutely need to do. Doesn't matter how good everything else is. So in Drew Notebook Cup, this was the problem. Like we could detect the ball well, but we didn't listen to the game controller, so the robot couldn't play. That's the game. So, and if like also this localization kind of thing, fine, right? So I mean it's kind of an extra thing, but here, kind of okay, maybe we detect the ball, and let's phrase this differently: detect the ball in the image. Okay. Then, what do we need to do next? What happens after this here? We know where the ball is in the image, so we have image coordinates.
Some kind of coordinate transformation, so we know how many steps to take in which direction, or how far we should go.
Yeah, I mean basically just calculate. Calculate relative ball position. Where's the ball relative to us? Right? So we just know where it's in the image, right? So what do you think needs, like, what additional information do we need to do to do this calculation?
We should know where the enemy goal is.
No.
Okay.
We know, like, we have an image coordinate pixel basically that says okay, this pixel is the center of the ball. Now we want to know where is the ball relative to us. What do we need to do? I mean, it's pretty easy.
Okay.
Like I think you maybe complicate head position.
Oh, yeah.
If you look to the left, to the right.
Yeah.
Right? So we have an image. Where is it relative to our body, right?
Yeah. So
where did you put the camera, right? So this is like a piece of code that also needs to be written, right? That gets the data. So the hardware has a function, or like the hardware SDK gives you a function that returns this value, right?
Yes.
Where are the joints? It's actually the same for all the joints, right? So there's nothing special about the head joint, but you need to know in which direction you actually look, right? So okay, this information, and then we can, like when we have all the joint information, so like actually you need to need to know a little bit more than just the head position. The head position is sufficient if you're standing straight.
Yeah.
But what if you're like basically falling? Like it's the easiest to imagine if you're falling to the side or in the process of falling to the side, right? Then just the head position relative to the body doesn't help you, right? You need to know that you're tilted, in a sense.
Yes.
Right? So for Booster, they already calculate this correctly. So for Booster, we just need to call a function saying, oh yeah, give me the head position.
Oh,
so
that's convenient.
But for other robots, that's not, right? So you would need to calculate, okay, how is the position of the body? And then you get the relative position of the head towards the body, and then you do this. But basically you do this calculation just multiple times, in a sense. But then, okay, you know how where the ball is relative, right? So,
yes,
to you. Okay. And then we can say we have a ball position here. I mean, this ball position. Okay. What should we do with it?
Maybe communicate it with the other robots. It's possible that the other players are more closer to the ball, so they should go there.
Yeah. Okay. Yeah. Just put So, do you think it's a good idea to immediately communicate this? Like, given the RoboCup context? Like, have you read the rules?
No.
Okay. So you can only send a few messages per second, right? So everything you wanna like broadcast to the other robots should be in one message.
Yes. So you should.
If you want to communicate something else other than the ball position, right? And do you think the relative ball position is useful to communicate?
No, not really. Only if you also communicate the robot position if the robot knows where it is.
Yeah, that's correct. So this is what we did with Senhaus, basically, that we communicated both positions, and then everyone could draw their own conclusions, right? Yeah.
Maybe we should have something like a communication queue where we put information we want to send.
Yeah, we do it differently, but
okay.
Yeah. So queue is not the correct word for this. But this is more like an implementation detail.
Yeah.
Because you need to have a structure of the data you want to send, so you can easily parse this. So just adding data to a queue, and it could be different every time. It's just more annoying to deal with.
Yep.
So, okay, so if you want to have some sort of localization, right? So technically, like localization would be something that says I'm here with some margin of error.
Yes.
So we had this idea of we don't actually need this, right? We can detect the ball, and if we have a rough idea of in which direction it should be kicked, we can just kick it. We don't really need to know where we are. So it's a difference saying like I'm 1,000 centimeters behind the center line and 1,200 millimeters to the left of the midpoint of the field. Like this kind of information is very, very different to shoot 30 degrees to the left. Right? So if you just roughly know where you need to kick or where the ball should go, if you can calculate this without exactly knowing where you are on the field, then you don't need to look the localization.
But we can't communicate the ball position with the other robots if you don't do self-localization.
Yeah. So this is a little bit more tricky, right? But you could use other mechanisms, right? You can just emit a sound, saying like I'm here. Then the other robots would know like where you are relative to them.
Is this allowed?
Yeah. I mean, that's what other like humans do as well. Hey, I'm here, play the ball to me. Can totally do this. Yeah, so I'm just wanna showcase you don't really need this localization.
Yes.
And also, like, when do you need localization? Like usually, like if you just think about one player, you need localization whenever there's a decision to be made. So should I walk over this line? Should I kick over this line? That's the only thing like where localization comes in, really. Like when you're like a striker and you have the ball and you like need to decide what you need to do, right? Like also obviously for strategy, like you want to know like, oh, I want to go to this position, right? Those kind of things, right? But if you don't have this, then it's not immediately a problematic. Problematic is if you classify the lines wrong. Think the outside line is not the outside line, or those kind of things. Or the goal line of your own goal, you think it's the goal line of the opponent goal. And that's why you kick there, in that direction. But this is a classification problem.
I thought at RoboCup when the goalkeeper was walking backwards inside goal or not standing in the middle, that is just a localization issue.
Yes, and why this localization issue happens there? Because it always has like small errors in where it thinks it is. And the error is calculated differently every frame based on the lines or what it sees in front of it. So it constantly wants to correct. So it wants to move constantly. Like it never stops, right? So if you move constantly and you never move exactly how you want, so you increase the error. So over time, you drift away because not for localization, it's not as we do with the nows, we don't use the lines as the only input, but also the odometry, so the steps we did. And this is always added, so to one step or another, right? And if you like accurately measure which steps you did, you know exactly where you are if you know the starting position, right? But also where you are after 10 steps depends on the previous steps, right? So if every step that you measure and you take has a slight error and you trust the odometry, so that's what it's called, then over time you always have like an increasing error.
Okay.
So, and this happens with the goalie, and that's why it drifts.
Okay.
So if we would just disable localization for the goalie after it roughly went to the goal area, it wouldn't drift.
Okay. Good to know.
Yeah. But if we want to have some sort of localization, what do we need to do? I already explained a little bit.
Like look at the field lines?
Yeah. So So we need to detect features in the field, right? So
yes.
Let's do it a little bit generic. Detect field features, could be lines, intersections, or goals, right?
Yes.
So and then we can have some algorithms, there are different ones to sort of estimate where we are. But for this, we also need an idea of what the feld is. We need to have a map of the field, right?
Yes.
So otherwise, this doesn't help us at all.
Of course.
Right? So here we said we want to detect the ball in the image. Do you think there's something that also needs to be done before this?
Detect the play state?
What?
We should only do this if the game state is in play?
Yeah, this is implicit. No.
Okay.
What if the robot looks away? Like what do you need to do to, if you want to detect the ball?
Rotate your head.
Yeah. So, for example, think there should be more happening than just turn the head around. Yeah.
Also rotate your body because the head can't rotate 360 degrees.
Yeah. So basically, it's just looking for the ball, right?
Yeah.
So okay. What else needs to happen in a robot?
We still need to kick the ball.
Yeah. So.
Or even be able to walk to some position.
Yeah, so basically a walking engine, right? So.
Yes.
So, okay, so currently we are doing this with just a reinforcement learning model, right? And
yep.
It gets as an input a vector in which direction it should move.
Okay.
So, but then, okay, we want maybe a little bit better behavior than just the robot looks around. If it's a ball, it sees a ball, it goes to the ball. So, should we have a little bit more sophisticated behavior?
Probably yes.
Yeah. So, what do you think could be a more sophisticated behavior? Right now we're just walking straight to the ball if we see it.
we should also detect obstacles on the way.
Mm-hmm. Okay.
Like we don't want to push down the robots, like our players or the other players.
Yeah. Okay.
They.
Okay. So yeah, maybe you don't know the word, but yeah, we would need to do some path planning, right? So we just want to replace the walk straight to the ball with something that uses more information. Okay?
Yep.
Obstacle. Detector. So. Yeah. All right. Yeah. What should someone do that is not going to the ball?
Maybe at least some players should stay in their own part of the field to defend with.
So basically, we need a strategy.
Yeah.
That could say, based on player, it does something, right? And then path planning, walking engine, right?
Yep. There should be maybe roles for each player.
Yeah. Like how you this is like I don't want to go like that much into the detail, right?
Okay.
But it's more like, okay, this is something you need to do. Like, okay, everyone should like know what to do, right?
Yep.
And so the interface, like what is doing in RoboCup soccer? Yeah, go to a point, right? It's always go to a point, right? But this has different meanings. The point could be the ball position, but also it could be a point on the predicted ball path of a kick of an opponent, right? So you want to intercept a pass from the opponent or kick of the opponent, right? The goalie also, like oh, there could be a kick, so I will go to a position that I think where I can intercept the kick.
Yes.
This kind of thing. So on the motion side, should we have a little bit more than just walking? What else do we need to do?
We need to stand up if we fall down.
Yeah. So. Mm-hmm. So this, right? And so I also think this is annoying sometimes. So this like basically also should go into strategy. So if the robot falls that's closest to the ball, well, it maybe shouldn't be like the designated striker or something like this.
Yes.
Because it's sort of like not playing for the duration of getting up. Yeah. So, anything else?
We still can't kick. I think that's something different than walking.
Yeah. Not necessarily, but yeah, we could have special kicks. I mean, for most team, it's just walking in the correct angle towards the ball.
Mm-hmm.
So, some things that I'm interested in. We should be able to foul, since apparently this is never punished anymore. So, yeah.
I don't know. like we need to listen to the whistle at the start of the game.
Yep.
But you already wrote it down?
Yeah. So here's something regarding this actually. So it's actually a little bit more complicated. So here you need, like, first, okay, listen to the network traffic on a specific port, and then you have the game controller receiver, right? And then you could save this, whatever you got from the game controller. So you want to detect the whistle, so you need to have like some sort of audio recording first. And also, like, not this year, but the year before, we had to detect the start of the ready phase. So when we could walk into the field by a referee pose. So the referee just lifted its arms, and then you need to detect this, right?
Yep.
And whenever you don't detect something, you get the message that it happened a few seconds later.
Yes.
So what this means is you have two different game states. You could you could think it's ready or set or playing. Set you always know, but you could think it's ready or playing, even if it's not, and other way around. So this is important to differentiate. So because robots don't get the true game state, and this is something you know, right?
Yes.
And also, like, just from a debugging perspective, is due to like just delays in the handling of the game controller, you actually have three game states. So, for example, you could whistle, right? Or the referee whistles, but then the robots could react and say, like, for them it's playing, but at the same time the game controller should click play, but and then the true game state is also play, but this happens maybe with a few seconds delay after the whistle. So the true game state is not actually true for a few seconds. So those kind of things could happen.
Okay.
Yeah. Which makes synchronization a little bit annoying, but so this is just something that happens. That could happen. So, but yeah, the whole game state thing is just this, right? Or it could be as complicated as this, right? Yeah. And so what we here we don't really have is a separation with a behavior. So at the moment we have like a different behavior scripting language that would react to some of the calculated values and then create other values. For example, say that you want to walk to something. Yeah, but like how you implement this and like what do you do in which module doesn't really matter for the general structure of what you need to write code. So technically, our current booster implementation, what's implemented is we listen to the game controller, we can detect the ball in the image, calculate the relative ball position, we do have some localization, and then our walking engine is just calling the reinforcement learning model with the vector in which direction we should walk towards the ball. When we are close to the ball, we turn towards the goal, around the ball, and walk straight. This is what we're currently doing. So not even that complicated as this here. Yeah. And we don't listen to the whistle on the booster yet. So, yeah. So yeah, so this is what needs to be implemented.
Yes.
Okay, then you want to implement it now?
We could start.
Yeah, so. Okay. Yeah, I mean, you can just delete this. Can you read my screen, or is it too small?
I can read it.
Yeah. Okay. So we can do like, okay, I want to like do Rust a little bit. So not C++. So in Rust we have a tool called cargo, and we can just say cargo new, and yeah, let's name this project. And since I'm doing it on my own, call it solo. And then we have a hello world program. So we can build this with cargo build. Yeah, first we need to go into the directory, and it builds a hello world program. And here it's in target, and then we debug, because debug build, and then we can call it. So we can just call this, and it says hello world. Okay. So here we just have a function. So this is a keyword. In Python that would be def, right?
Yep.
And yeah, we always need to have a main function. And here, so this is important. If you have what looks like a function call with an exclamation mark, then it's a macro. There is a function version of it, but yeah. So this is a macro. So this would generate some other Rust code that actually does this, what we want to do. So especially for like those print stuff, it's a little bit annoying to use the actual Rust code.
Okay.
Yeah. So, but yeah, so this is just what the exclamation mark here means, because usually you would call functions differently. And let's try writing different function. So, and then you can call this here. Let's see if this works. So now it says 2 times. So this is just a normal function call here.
Yep.
This is, I think, not too surprising.
Not really.
Right? Okay. So now we want to do like I'm prepared a little bit to writing the game controller receiver code. So, and what we need to do, well, I mean, you wrote this in JavaScript once, so you should know kind of like what's needed. So we can create a const variable, right? And we can give it a type. So it would be and yeah. So now we have a const variable that we can use, and we could also print this. I think it's like this.
You can also do cargo run. You don't have to build every time.
Yeah. I mean, yeah. I wanted to make it as simple as possible, not just use too much code. I can also generate the whole code with an AI model and not write it by hand. So I know I can do some shortcuts if I want to.
Okay.
Yeah. Okay. So here we have a constant for the game controller port, so which has this type, because it's 4 integers long. Okay. And here we can also do this. Wait a second. Yeah. What was this again? So here. So you know that we always have a header in the game controller things.
Yes. This is the header for the messages that robots get, not the true game data.
Yeah. So can I put it here? Yeah. So here, so this is basically what I'm implementing. So the struct header.
Okay.
And yeah. Okay. So yeah. So, and what do you think this is? Like, do you have an idea? I think you've seen
like
C code before, right?
Yes, it's like reference to an array of 4 unsigned integers that have 8-bit length.
Yeah, it's exactly right. So, and here we say like this would be a string here, right?
Yeah.
But we interpret this as bytes, meaning we so each ASCII character has an integer assigned to it.
Yep.
So this is what's happening here. Yeah. Yeah. So and this basically we just do this here, so we don't have to like we will get like over network bytes first of all.
Yes.
So and we want to compare if the header matches. So we listen on the port, and random shit could happen, like could just arrive. And then we don't want to pass the bytes, put it in a string to make a string comparison to this string.
If you can store it in bytes. Yes.
Yeah, and then so we store the string in bytes, and then we have an easier comparison later on. So this is already an optimization, right? So don't really need to do this, right? So okay, here, so this is next line would be something like this. So here, basically saying, okay, create a basically a socket object, so and give it the parameters we need, and here so this is basically use a library here, and similar to C++, everything in this sort of namespace is comes with Rust, so you don't need to install extra libraries or something like this. Okay, so this is something basically I just found online that you like need to do this. Okay, so here, so bind expects a string. So we say like call the format macro with this basically.
Yep.
And this similar to what you already know from other languages. We listen on all the IP addresses, so we don't really care where it comes from.
Because we don't know it.
Yeah, but on a port, right? So like when you do a web server in Python, you also always say this zeros.
Yep.
Similar to this. Okay. Yeah. Okay. Next line. So we could listen now to like on a socket, and network traffic could arrive there, right?
Yes.
So, but we need to do something with the data. First of all, we need to store it if you want to work with it. So we create a buffer. Can you sort of infer what this syntax maybe be?
We have a mutable array called buff that is length of 2048, but I don't know what the zero U8 means.
Yeah.
Like,
Okay.
what does the zero?
So first of all, this is an array.
Okay.
So, and you correctly said it's a mutable array, right? And you call it buff. So for buffer, basically, we could also say buffer. And here, so this is basically a 0 2048 times. But a 0 can have different types, right?
Oh, okay.
So is it a floating point 0 or integer, and with integer which length, those kind of things. So this is just, U8. This is a type, basically.
Okay, so we have an array filled with zeros.
Yeah. This is what's happening there. Yeah. Yeah. So it's basically unsigned 8-bit integer. So that's what it means. Yeah. And since 8 bits, so this is what typically network traffic is. So each individual data point basically is always a byte, so you send different bytes. So what this actually means is we can read or store 2048 bytes of data. So if the game controller message is longer, then we have a problem.
Yes, but I think it isn't.
No. It's much shorter. So, but yeah. Okay. So. And logically, what needs to happen now? So we have a buffer that we could reuse, right? So what should happen roughly here in like normal words?
We should have like a loop that writes into the buffer from the socket.
Yep. Exactly. And this is how you do it. So.
Yep.
Yeah. I mean, could just do this. No, we cannot use this. Okay, so this is, we skip this. This is a shorthand for error handling. So you can you get an okay or an error from this kind of functions, like from a lot of functions. And you could actually, you have to handle that you can have like both cases here. So that this bind function returns either an error or an okay. And if it's an okay, then you would need to get the actual value, so what we want to have here, out of sort of a container. And this question mark just does it for you, but then you need to also set the return type of the function correctly. Okay. So this bind function returns the result type. And the result is sort of like a container where the value is stored if it's didn't error or the error message. So, and since kind of like then you have an error here, right? So the function would stop here. So, but then it needs to return something. And it's not nothing because you return an error here if this function has an error. So the main function needs to have a return type.
Makes sense.
So here. So we built a loop that does some things, right? So yeah, I mean, it's not really useful, but it kind of shows you like how to work with this kind of stuff. So next function or next line from the internet, it's sort of, so here the socket kind of thing. So the UDP socket object has a receive from function.
Yep.
So the socket is initialized with the port and like how we want to listen to it. And we give a mutable reference to the buffer. So first of all, reference, but the buff is mutable, so it has to be mute. If you like, for example, socket we cannot change because it's immutable.
Yes.
Right. So, and here, of course, this can also error. So we also have the question mark. So we save a lot of writing weird Rust code. Yeah. So, and here the receive from function gives us the source address. So now we know what the game controller is. So later on, we could also detect if the game controller IP changes. Could be useful for some detecting some interference or something like this.
But we should store the address anyways.
I mean, yeah, right now we don't do anything with it. So, but the more important part, we get the number of bytes that we received on the socket. Okay. So, and then we can do something like this. What do you think happens here?
We store the message we received into data. Like the bytes from 0 to number of bytes from the buffer.
So this is basically slicing, right? So basically create a new object. So this is no, this is a reference. So I think we only have like we don't copy data here. So this is, I'm not 100% sure what happens here. Like basically data is an array in the end, right? But I'm not sure if we copy the data from the buffer or not. Yeah. But in the end, we could just basically pass the first bytes. No, the version is here the fifth position. Fifth byte should give us a version, right? And then can also the next byte should us give us a game state, and then we can print this. So if I just run it, what do you think happens? Do you think it works, or would it crash?
It could work, but
let's see. Oh, yeah, I still have the game controller running. But this is wrong, right? It's not the game state ID. I think it's a time or something. Like, what's the...
But the version is
correct.
Yeah.
But... yeah, the packet number. Yeah. So 5, 6, 7, 8, 9, 10. So yeah. It's just a demo code anyway. So game state ID null or 0. No idea what this is, but I can now like go ready, set, play, and I need to like wait. I mean, it detected 2 now because of set. So, but now it's switched to 3 after the timer went down. So the 15 seconds after I press play, it's actually communicated. So
It works.
Yeah, so this is how you, in a very shitty way, write something that listens to the game controller. And that's all there is to it. We could now create some variables where we write this kind of things in, right? So we can use it later. But yeah, for now, like this first thing is done, right? So
yeah.
So if you have another component that needs some information from the game controller, we need to make sure that we correctly give the data from the game controller to the next piece of code that needs to do something with it. But just receiving is done.
Yes.
So we build basically one of the boxes that we need to do.
Yeah.
Okay, so and this is all for now. Stop the recording.